Docker Inc. is a sponsor of our ebook series on Docker and the container ecosystem. Learn more about Docker's perspectives on these timely and important topics in our latest ebook about application architectures and microservices. It's available for download at thenewstack.io. Hey, Alex Williams of the New Stack here talking with Scott Johnston of Docker. And our topic today is the emergence of microservices as a major theme that we're seeing play out in the market. Scott, good to have you here for this conversation.
Good to be here, Alex. Thank you for the opportunity.
You bet. Scott, I wanted to discuss a little bit with you about the context for microservices, the historical context for microservices in particular. How do you view the historical context for microservices and how that speaks to where we are today?
Sure, Alex. And I think it is helpful to view this movement in the context of history and call it parallel trends or trends that have gone before. I think one of the most powerful lenses, or for me, one of the most useful lenses around is to view it in the context of the emergence of DevOps as a movement or as a way of approaching the application delivery pipeline. And there are many threads in there, but one of the important ones is giving teams the ability to ship changes faster. And part of enabling that ability is to make the surface area of the change smaller. And so what you get is smaller changes can flow faster through a continuous integration system or an application pipeline. And if you look at that as a pressure on application architecture, you can see how that very much supports the direction of microservices, meaning make the unit which is under application development and shipping through the pipeline small enough such that teams can make change, ship it faster, get quick validation that the change is the appropriate one and has the appropriate quality for going into production. And I think looking at that, you can see how that almost organizational process desire naturally kind of pushes on architecture to deliver an architecture that can work in that framework.
So if you would look back to 5-10 years ago, what did that surface area look like, and how has it changed?
Yeah, no, that's fair to put in context DevOps as well, right? Which is, it was just more efficient for teams to reason about these large applications, and indeed, the call it earlier generation of architectures, call it Java J2EE type style applications, were significant monoliths. Or at least very large subsystems interoperating with other large subsystems. And I think that was just a result of early days of reasoning about application architecture, and when you're bringing things to the web, very much kind of modeling client server. And so you take kind of these large client server apps and you bring them into Java and bring them to the web. And so, you're talking kind of large teams, all trying to reason about large blocks of code, large chunks of code, and as a result, kind of moving at a pace that you might expect with that, right? You see them moving in terms of taking weeks and months to ship changes through the app delivery pipeline. And at the time, that was best practice, right? Because users were more concerned about bringing capabilities online to the web, and everyone was moving about the same pace, and so you didn't get a sense that you were slow or that the relative changes. In fact, shipping every several months back then would have been considered way faster than previous generations, than client-server generations, where your shipping cadence looks in terms of years. So I think that's kind of where we were, and just the comparisons were such that no one thought that was out of date. But the competitive pressures on the business, the rise of the importance of software and applications has made kind of folks wake up and say, wait a minute, there's got to be a better way.
That process people went through in developing these monolithic applications did require large teams, and it did take weeks and months. And I'm curious what you see as shifts we saw in the market, preceding Docker. Some people talk about, the rise of, being able to spin up VMs more quickly. Others talk about the advent of like new frameworks, and particularly about Ruby on Rails. Are there points in time that you think about that you see as noteworthy that speak to the evolution and where we are today?
I think you hit on some good ones there, and we can explore those and take them and add to them. So yes, I think on the development side, the development of Agile in general, and then call it application frameworks to support that in specific, and you gave the Ruby on Rails example. I think it's a good example of just development teams wanting to move faster, having the tools to move faster. But of course, the speed is measured by not just how fast your development teams work, but the throughput of your end-to-end app delivery pipeline, which of course means app development teams have to work with their operations teams, right, to deploy apps and update apps and change apps. I think programmatic infrastructure absolutely gave folks a taste for what's possible on the operations side. So you have programmatic infrastructure offered by VMware on-premise, or call it VMs on-premise, and then cloud vendors, cloud providers in the cloud, with Amazon obviously leading the charge there. And so all of a sudden, you gave teams a vision of what could be, that they no longer had to call their favorite hardware or server or OEM and wait for weeks, if not months, for a shipment of servers. They could programmatically dial it up. In the midst of that, you saw the configuration management, or call it IT automation, startups like Chef and Puppet and Ansible and Salt come in and show how, given programmatic infrastructure, given development teams want to move faster, how do you lower the friction to moving changes through the pipeline? How do you make environments consistent so that you don't have breaking changes every time you push from one stage to another or from one server to another? And so a big goal of the automation vendors was to create consistency between those environments in an automated fashion, so you could spin up the entire stack, right? So you start at the bottom, spin up the metal, quote unquote, in the form of a VM, whether it's in the cloud or on premise. Use configuration management tooling to automate such that that environment looks exactly like the environment on the developer's laptop or on the build farm, and then you're able to kind of push changes faster through it. And then I think in the midst of this comes Docker, which makes it even easier to maintain that environment consistency, server to server and stage to stage. Docker had a lot of good tailwinds that were present in the market before it even showed up. And as a result of which, I think that's why we've seen the adoption that we have in the last 2.5 years.
So configuration management really was designed for the application level. And now we're like looking at distributed systems in a much different kind of way to compose applications. What is the change that you're seeing that's reflected in the in the market today as it relates to configuration management and where we're seeing moving forward?
If you actually follow the provenance of config management, it actually came out of, if you go all the way back to like early aughts and even in the 90s, you can see the provenance coming up the stack from sysadmins actually. Whether you look at the Lisa conference notes or you look at the early CF Engine prototypes in the mid 90s. And so what they're trying to do, of course, is sysadmins appreciated the need for consistent servers. And so config management started at the OS level, really trying to make those OS environments as consistent as possible between servers and between app lifecycle stages. As they succeeded there, maybe to your point, Alex, as they succeeded there, they were moving up the stack, right? And they were trying to then make applications and application infrastructure consistent. So, Tomcat, Java servers, and then the application configurations themselves. In the midst of this, kind of Docker shows up and shows another way of which you can think about these environments, and particularly because Docker focuses on the application layer, how to make that application environment consistent. And so I think the difference is, and this is telling, and I think it's also the reason why you see such innovation in this particular part of the stack, which is so much of the tools and configuration management in particular came up in a world that wasn't as distributed, that was more monolithic in nature, and was really focused on the individual node level. And now, of course, when we think of microservices and distributed computing, we think of multiple nodes, multiple containers, all orchestrated together, right, to deliver an application or deliver a service. That's a driver as to why we're seeing so much innovation at the orchestration layer, is because let's call it the lower layers in the stack, or the node layers in the stack, have really been the focus of so much work for the last decade or so. There's many more cards to turn over there, but I think that the distributed computing theme, which we've seen from Corba in the 90s, and then, as you mentioned, SOA in the aughts, where we're now revisiting it with microservices. But a big part of that is orchestrating the services that are resident on the different nodes.
So containers offer a new evolution, don't they? What is that new evolution that containers offer? I mean, you talk about being distributed, by default. We see people not taking a different approach. People don't build the app, then break it out. They treat it differently.
Yeah, they do, right? And what containers have done, at least as far as what we see, is it gives an upfront contract, if you will, or a clear boundary between the developer and the operations team and the sysadmin. And so right away, it kind of gives a reasonable starting point where the surface area for the developer is known and the surface area for the sysadmin is known, right? Mm-hmm. And in one sense, we could do this in the past, but before there was a standard to do it, there's a lot of friction, right? A lot of uncertainty into where to draw that line. And I mean, just as evidence, microservices term was coined before containers showed up, right? Mm-hmm. It was coined, and Netflix, of course, is the poster child. But Netflix was doing microservices, quote unquote, if we look at it from an application architecture pattern. They were doing it before containers showed up. But just they were very much the cutting edge. They had figured out all the contracts, not only between dev and ops, but between all the different services themselves. And then what containers did, of course, is come along and just make it much more of a commodity, or much more easily reasoned about for folks who aren't Netflix, right? You don't have to be Netflix now to have an understanding of where you draw lines between the application and the underlying infrastructure, because containers kind of out of the box, Docker containers out of the box, give that for you. So I think that's one of the tremendous benefits we've seen with the rise of containers. Is just that contract is defined up front, and it's defined in such a way that the surface area for the developers is relatively straightforward to reason about, and the surface area for the sysadmin is similarly straightforward to reason about. Containers
provide a level of abstraction, right? So developers can be sure, right. They can be relatively sure that what they're building out will run in production, and that then creates fewer stories about the incongruity between the developers and the sysadmin.
Yes.
What are some of the citations that you guys talk about when you think about kind of like that old approach to throwing the code over the wall, so to speak, so the ops could then try to get it to run? What are customers saying to you in that regard?
I think it's a theme kind of in our conversations, or our conversation today, Alex, is that surface area I keep using as one label, and when that surface area is modest, right, and the default pattern for Docker-based microservices is one process per container. So when it's relatively defined and modest, then the iterations between the developers and the operations teams can be rapid, right? Because there's not all this kind of discovery going on the ops side as the app moves over. And maybe in answer to your question, in contrast, before when big applications moved into operations, there's a whole adoption time, and I mean, you and I probably both remember kind of runbooks being written and specs being defined, and all this kind of information that had to be predefined and shared, and of course it was out of date as soon as it moved between stages, and that was just because the surface area is so significant of these monoliths that there had to be all this upfront education going on and big handoffs and such. And I just remember working through this back in the day with app servers in the 90s, and even with the first PaaS in the last, the early part of the aughts, just the size was so significant that you'd spend weeks migrating this thing into operations and answering questions and doing performance testing all before the thing actually went into production, right? Staging used to be this big deal where everyone kind of sat around, not sitting literally, but everyone was looking at the app as it's in staging to try to figure out, like, is it doing what we think it's going to do and such. Compare that with the world of Docker-based microservices, where the change, the size of the change you're moving into production is significantly smaller, And so the development team and the operations team kind of look at that together and very quickly kind of understand what's been changed, what's the order of magnitude of the change, how risky is it, and that just makes it much easier to reason about. Now nothing comes for free, right? You do have, in many application cases, orders of magnitude more of these objects now coming towards you, right? Because you've broken this thing out into a number of different microservices. But the difference is the changes are isolated to an object or two, and you're not having to put at risk the entire application every time you make an update. And so that's where we're really seeing the benefit, is that you deploy 50 different containers for your microservice. You're not, or rarely are you going to ever be updating all 50, whereas in the monolith days, you'd be pushing this big change, and there's an update somewhere in there, right? But because it's a monolith, it's very difficult to kind of draw a thread all the way through the app and understand the impact and the downstream consequences of even small changes.
Mm-hmm. How is that affecting how teams are organizing around building out these decomposed applications?
And I think it's one of the more interesting things to see is that you do see teams downsizing, if you will, or not in the sense of laying people off, of course, but you see it going from large application teams that are reflective of their architectures down to smaller teams, which are also reflective, but are reflective of the microservices architecture. So it's, in some sense, Conway's law playing out in IT, where you see team sizes, and we have many anecdotes of team sizes that were hundreds of developers, hundreds of engineers organized by these big functions, going down to, you call it the 2 pizza teams, right? To use, I believe it's the Amazon phrase, where you've got 5 to 7 developers and a product manager and QA and design, and they're all kind of organized around their microservice. And what we're seeing change, of course, is that they don't throw it over the wall anymore, but they follow it into production and take a role at the proverbial pager duty to make sure that the app is functioning as is and as they designed it. So yeah, smaller teams is the summary there. Of course, not just Conway's law at play there, but you think about teams and communication complexity within teams. It's a power law, right? It goes up squared, right? Every person you add to the team, n squared connections are now required. So the smaller the team, faster communications within the team, easier to get everyone on the same page, faster they're moving. So it's the equivalent almost of the application innovation we're seeing, where you can move these smaller changes through the process faster. The actual team dynamic supports that as well. So it's almost like, going back to the top of our conversation, it's almost like just natural forces at work here that are driving this change in the application architecture, because it's supported in how humans work effectively together as well.
So how do you take your customers through this process?
Yeah, that's a phenomenal question, Alex. And I mean, honestly, as a 200-some person startup, we have to balance our own focus on a day-to-day basis, a month-to-month, year-to-year basis. The short version is we provide some enablement in terms of training, and we provide some use cases and good examples in terms of customers that have come forward and shared as we discussed kind of at DockerCon and other ways. But at the end of the day, we are first and foremost a product company. And so we lean very heavily on partners whose business is transformation, organizational transformation. And they can help the customers kind of crawl, walk, run through that transformation. And I'm happy to list them, but it's folks like IBM, and Accenture, and Booz Allen, and CSC. Those are example partners who understand the revolution enabled by this new architecture, but also understand organizations very, very well and how to lead those organizations through that type of change. The other thing we do, Alex, just to, I guess, be specific, is we very much advocate for the small internal team doing a small proof of concept first in the process versus trying to boil the ocean and do a complete replatforming out of the gate. Because that way nothing breeds success like success, right? So small team, typically a skunkworks project, typically something that's not touching the heart of the organization on first get-go because, risk obviously implied with that. And we encourage our customers to start with that, have that team demonstrate success, and then that team really becomes the advocates and the champions internally for this new approach, and they can point to concrete results, right? They can point to faster deploys, more reliable applications, the team itself hitting its objectives early, all the goodness that comes from being able to ship faster with lower surface area of these objects.
So those small teams that you're working with, what kind of things are they doing to get started, and how are they migrating then to developing these different kinds of application architectures that embody the concepts of microservices?
The patterns we see, I'll share a couple with you, and you can steer me accordingly.
Okay.
They'll start typically with a greenfield app, to be clear, and that is typically along the lines of a web type application or a mobile type application, and those applications lend themselves first very well to stateless nature of containers, which is how obviously Docker started. Now with the recent innovations in the last 6 months, we have more support for stateful services, but the pattern of starting with kind of a web application, which is stateless on the front end, obviously lends itself well to web apps and mobile apps. We do see brownfield examples. So a small team might take an existing Java app, say, and put it in a container just to demonstrate the portability aspect, demonstrate that even an existing application that might be more monolithic in nature can actually move faster because now the environment are made consistent thanks to the containers across, say, QA and staging or staging and production. But that I will say is more the exception than the greenfield use case.
Okay, so every company is different. So some companies might be highly reliant on Java. Others might be they may be more of a Python shop, for example.
Yeah.
I guess the question is are there differences in how these? There must be differences in how these different companies approach, how they build out these microservices environments. How do you help guide them through that? Because no one shop is the same.
No, that's true. And more often than not, though, concepts like a web tier and a data tier, as a simple example, right, or your load balance tier, and then your web tier, and then your application tier. The concept of even a simple LAMP stack, right, that does translate across languages relatively easily, and so that's often a good way to get started, right? Is break out a LAMP stack example and say, okay, your load balancer is here. Then your next tier of containers is going to be your web servers. Those are stateless. Then behind that is going to be a couple application servers. They more often than not do not have state, or they're going to persist their state back into the data tier on the back end. We find that can accommodate Java, it can accommodate Python, it can accommodate Ruby, relatively straightforward.
Can you help us understand the Docker's architectural philosophy about microservices, environments as embodied in the offerings that you have been developing over the past 2 years or so? We just came out of DockerCon Europe, and you introduced the Universal Control Plane. You made the acquisition. You made the Tudum acquisition, which is a big part of that. You're talking about containers as a service. We see lots of different products and services from Docker emerging. I think it'd be helpful for people to have a level set on your philosophy about all those products and how you embody that into your own development.
Sure. I mean, the philosophy generally has been to remain agnostic in terms of the technology choices that developers would like to use, and remain agnostic in terms of the infrastructure that the operations team wants to deploy on. And so we work very hard, and these products themselves are designed to give maximum choice to development teams. So if they want to use Ruby, going back to our last conversation point, they want to use Ruby, if they want to use Java, if they want to use Go, there's nothing limiting them to making those choices. And indeed, we see and anticipate kind of more and more kind of mixed technology choices, because once it's inside the container and if you are using microservices and a RESTful, RESTful APIs between the services, you really don't care kind of the specific stack that's inside the containers. And so we work very hard to kind of maintain that abstraction, so the developer doesn't have to be concerned about what's happening outside the container. And that goes not only just for language, things like language choices, but also networks, right, and specific storage implementations. And so a lot of the announcements you saw were around providing tooling that makes it easier for developers to continue to basically understand that abstraction and be, in some sense, protected by that. A lot of the tools are focused indeed on the operations side. So you mentioned UCP and Tutum. Those are examples of tools that certainly have a developer self-service aspect to it, and that's deliberate, where we want to facilitate this rapid movement, rapid iteration of teams, and moving quickly through the app dev pipeline. But another very important aspect of those tools is giving operations teams the tooling they need to provision the infrastructure with Docker daemons and provision it with Swarm clusters, and then really importantly, set policies and set access controls that still give them a level of security and control and governance, but does it in a way that allows the development teams to self-serve and deploy into these provisioned and available clusters. And so finding that balance where we're giving ops the control, but not slowing down this process, because we've been talking all this time, right, about speed and the speed that's enabled that's enabling these teams, that this new architecture enables these teams to move faster, and our tooling needs to be able to support that while still giving the ops folks the governance controls they need to stand up and represent their side of the business.
You introduced universal control plane. It might be helpful for people to hear your description of it, and then we can go from there.
Very brief summary is that it's a software application that's deployed in a dedicated fashion, so on-premise or a dedicated instance in the cloud, that gives operations and development teams everything they need to deploy and manage Dockerized applications. Super brief level. And so what that means is an operations team can provision and configure a cluster, and then the tool UCP also provides a self-service interface for development teams to then deploy composed, either single containers or compose-based applications into that cluster and manage them and start them, stop them, rolling updates into the cluster, so on and so forth.
How does that speak to the evolution of of discussions and practices about microservices?
I think we were talking a little at the top about what specifically has Docker provided to educate or lead the market on this. I'd have to point to our Compose tooling as an example of really trying to facilitate, and Compose, for maybe listeners that aren't familiar, Compose is a tool that allows developers to describe multi-container applications, so really support the microservices type application architecture in a very abstract fashion. So it can describe a web container, a web server container, a database container, a load balancer container, and then describe the logical connections between them, but doesn't force the developer to specify network implementation or storage implementation. And then that description, that Compose description, it's a YAML file, moves through the application pipeline, and it's what either the developer or the system uses to deploy then the multi-container application into the UCP cluster. And in fact, Tutum follows a very similar pattern, just for a control plane that's based in the cloud, that's SaaS-based instead of on-premise based. And so right there, Alex, that's showing support of a format, an application description format in the Compose YAML file, as well as, call it, operational tools in the form of UCP to take that file that describes multiple containers interoperating and network together and deploying them into the cluster. And then there's further examples. So like once it's deployed, you can see at the application level, you can see the relationships between the containers that were described in the Compose file. And then you can operate on the application either at the application level or at the individual container level. So it allows multi-level view into the application itself.
That's interesting. I mean, I think Compose is one of the more interesting topics for me to learn more about, just because I think, it's just there's such a simplicity about it, right? There's essentially, YAML files being able to define, they almost kind of, they serve as kind of, they serve as kind of such a cornerstone for portability, don't they?
Agreed. And I think it's not unlike Docker, the Docker container itself. It's one of the reasons I think we're seeing Docker Compose also get picked up in terms of popularity, because it eschews to the same principles, right? So with Compose, a developer can describe something more complicated than an individual container, but there's an abstraction between that logical description of multiple containers working together and what is the specific network stack, or what's the specific storage stack, or what's the specific cluster configuration that multi-container app is being deployed into. And the beauty is that the developer doesn't have to worry about that when they're describing this in a Compose file.
Microservices almost can be described as like contracts in a way, right? And like so.
Yep.
And so the contract is actually embodied in that in that YAML file, or in that Docker Compose file.
Right.
And following that theme, perhaps then you could talk to us about kind of the interrelationship then of Docker Swarm, Docker Machine, Docker Compose, the universal control plane. Help us better understand kind of the flow here, how these are relating, kind of in this broader conversation about microservices that is the focus of our conversation today.
As we know, the industry is pretty quickly moving, and lots of new products are emerging every day. So it would be good to kind of just shape this or frame this a bit.
Right.
So one way to view it is that there's lots of exciting open source technologies upstream from universal control plane, and that universal control plane represents an integration and configuration of those upstream open source technologies, as well as adds additional proprietary software or commercial software value add in a way that makes it easier for operations and development teams inside the enterprise to use. And what I mean by that is you very well could put together, and in fact the early adopters, right, and many internet companies do this already. You could put together the open source products yourself that are specific to your particular implementation if you're an early adopter. But if you're an enterprise, you really want out of the box these tools pulled together in an integrated and configured way. And then what you also want, which is not part of the open source product, upstream products, you also want integration with your enterprise systems, things like LDAP and Active Directory. You want role-based access control. You want to be able to manage secrets as they're moving through your pipeline. And you want all that in an integrated way, so you as an enterprise aren't spending your own talent pool kind of maintaining open source and writing custom software and maintaining that custom software and having to kind of patch it when there's new releases of the upstream stuff, right? We're taking care of kind of all that. And so, specifically kind of Compose, Swarm, Docker Engine, those are all components that are embedded within UCP, along with additional software to achieve that objective that I was stating, make it easy for the enterprise to use the tool and plug it into existing systems. Compose is also found in Docker Toolbox, which is on the desktop, and that's where you also find Docker Machine. So Toolbox contains kind of Docker Machine, Docker Compose, Kitematic, and you can think of Toolbox as an analog for UCP, but instead for kind of developers' laptops or workstations, where they just want all the bits kind of installed, configured, laid down on disk in a way that they just work, right? That they're just going to interoperate together. Whereas UCP is that kind of philosophy applied to data centers and clusters and cloud deployments.
It appears you're trying to like appeal to like the spectrum of of developers and operations people who may just want to go into the toolbox and and build out these these environments themselves, or they can have it more as a service and being able to like have them all packaged together. It seems like there's like that part of the effort is to reach to both these like new developers who are new to container technologies, and maybe some of the more advanced users who are trying to who just want to have the capability to use the tools the way they want to use them.
That's right. I mean, I think the advanced users more often than not might be internet companies or companies with kind of extreme requirements, whether it's scale or whether it's availability or whatnot. And they're going to take open source tools and bend them to their will and then to their requirements. But the vast majority of enterprise users, developers and sysadmins, really want to focus on the application, right? The unit of value, their currency is building and deploying and managing apps, because that's what's delivering value to their business. And so they would rather not be in the bespoke custom tool business, or maintaining kind of custom configurations of open source plumbing. That's not where they kind of deliver value for their organization.
Just to kind of in this last part of this discussion, perhaps we might talk about some of the fundamental use cases that you're seeing emerge, in context with the tools and services that you're providing around, especially concerning with companies who are looking at developing out these microservices environments.
I mean, the big one we see as a landing point more often than not is setting up a CI, continuous integration environment in typically a development organization. That's where we typically start. And I think the importance there is the emphasis on organization, where it's not just one developer, but it is in fact a development team. And more often than not, there's a development manager and a QA person involved, and so they're setting up a CI. And so there you've got a flow where you've got developer laptops and workstations that are producing containers. They are checked into some sort of source code manager, GitHub Enterprise or another type of source code management tool on premise. That then automatically triggers a build in a CI, continuous integration tool. More often than not, that looks like a Jenkins type tool. And then after Jenkins kind of gives it the green light, it's pushed into a registry that's that team's registry, right? Their applications and their application artifacts are in that registry. And so right there, the team, without even going further, without kind of deploying the results of that cycle I just outlined, the team gets a lot of benefit, because now they're moving faster. Their surface areas for each individual are smaller. They're not having to coordinate updates to this big monolithic app. Instead, they each kind of own their microservice that together constitutes the app. And so that cycle, the speed at which they get just by affecting that type of use case, almost regardless of app, right? It could be a mobile app, could be a web app, could be a Java app, transactional app. Really is agnostic, and we've seen it be applied to all three of those examples and many other types of applications. Once they get comfort from that, the next step, or the evolution of the use case, if you will, is now starting to deploy those containers that constitute the microservice application, starting to deploy them further in the application pipeline. So they'll start pushing them into to staging, or to like a beta type environment where their users can start exercising the application and give them feedback. And then of course the evolution from there goes all the way into production. And so it's almost like extending the use case, starting with the development team and then growing the surface area of the different individuals, different functions involved, growing over time as different functions and different organizations gain confidence with what's being produced. There's a specific third use case that we're seeing come up, and it looks like this pattern, but it's often applied specifically to a certain type of infrastructure, kind of big data infrastructure. We've been calling that the the data processing pipeline use case. And what that looks like is the deployment target is, call it a data lake, data ocean of typically Hadoop clusters, where you've got analysts and data scientists building applications or algorithms that are consuming and producing their own data. And what the organization solves for is having the environment that the data scientist is building their algorithm, which is their laptop, be consistent with that of the data lake, because they want to have some confidence that whatever they're building locally is going to work once it's deployed into the data environment. And what's super interesting about this use case is that it's agnostic to the specific data type. So we've seen this kind of data processing example for genomic processing, right? So Broad Institute and Illumina and nearly every kind of bioinformatics company out there is following this pattern. We've seen this pattern emerge for financial modeling and analysis. Many of the Wall Street banks, as others, credit card companies are using this pattern. And we've also seen it with audio video transcoding. So, you're up-leveling or down-leveling your resolution, or you're translating the audio video from one format into another. Almost, regardless of data type, this kind of centralized data pool against which you're sending Docker containers with a specific algorithm or specific processing task kind of holds true or holds out. So those are just some simple examples, Alex.
I love that. I love those last examples of the data analytics capabilities that can come with, with using containers. To me, it's one of the emerging, really interesting areas that's coming out of the Docker container ecosystem.
No, I agree, Alex. It's very exciting because it allows that. I mean, if you look at Hadoop as kind of making data super accessible to organizations, bringing the Docker platform to that conversation is making it even more accessible to individuals, right? Who aren't developers, who aren't programmers, who are just putting together simple scripts. And so I agree with you. It's a super exciting emergent use case.
Great. Scott, is there anything else that you'd like to add before we conclude this interview?
No, Alex, I think this has been a full discussion. So thank you for the opportunity again to share our points of view on this journey and how the industry is emerging. Clearly, we're excited about Docker's role in it, and that microservices, where there was industry pressure and threads kind of pushing in that way, we really do believe kind of the Docker platform really makes it even easier for organizations to adopt this new pattern and bring all of its benefits to their organizations.
Well, Scott, thank you very much for taking the time to talk with us today.
Thank you, Alex, and likewise.